Well, if this class afforded us more time, I would tell you where this formula came from, and it's not super hard to derive. But before we get to the quadratic formula, just a quick reminder. Okay, this is something we saw in chapter 5 after we had talked about factoring, introduced the idea of what a quadratic equation is. And a quadratic equation is a degree 2 equation. Okay, you've got a power here. The two types of equations that we've solved in this class are linear equations and quadratic equations. Those are the two things that you know how to solve and various uses for those. And so up till now in chapter 5, section 5, we solved this by factoring. Okay, so just real quick, what that meant is first you set it equal to 0, then we factored this. X squared is x times x. My 55 is negative, so that means my signs are positive and negative, or negative and positive. There has to be one of each. And then we spent a little time, depending on the number, figuring out what factors of negative 55 are going to add up to negative 6. So if the number's bigger, it might take you a few more guesses. If the number's smaller, it might be a little easier to do. And so the two factors of 55 that add up to negative 6 are negative 11 and plus 5. Those are the two. And then we used something called the principle of zero products, which I called common sense, is that if you have two numbers that you don't know, I don't know either of these numbers. I know their format, x plus 5 and x minus 11, but I do know that when I multiply them, I get 0. So that means either the first number, the x plus 5, has to be 0, or the second number, x minus 11 equals 0. In this case, I subtract 5 from both sides. The first number is negative 5. Here, I add 11 to both sides. The second number is 11. And then that's my solution set. So we write our answers to quadratics as a set. That is something that I'm fussy about notationally. So please make sure to write your solutions as a set. Use braces. Some of you use parentheses. Parentheses is interval notation. So if you write your solution set like this, you're really communicating something completely different to me. Okay, so remember to use braces for a solution set, parentheses and brackets for intervals when you solve inequalities. Okay, so that just make sure you're doing the right thing in the right place. Okay, so the problem then comes, what happens if I can't factor my quadratic? Can I solve it? Well, up till now you can't, but now you're going to be able to. So here is what's called the quadratic formula. And the quadratic formula says this: the solutions to ax squared plus bx plus c equals 0. So that's a quadratic equation in standard form. It has to be equal to 0, are given by this format right here. So you do need to remember this. Okay, so write this on a 3x5 card, have it under your plate at Thanksgiving so that you can memorize it. Okay, so this is something you need to come in knowing. You can do a brain dump on your scratch paper as soon as I hand out the test and write it down. That's fine, but there's no formula sheets, no cheat sheets. So it's negative b plus or minus. That symbol right there means there's two solutions. There's the solution you get when you add these two things together. There's the solution you get when you subtract these two things. Underneath this root is b squared minus 4ac. That's if you are going to memorize this, which you should, that's where I would start. The b squared minus 4ac, start there, and then put that in with the rest of it, all over 2a. That's the format, where a, b, and c are given as the coefficients in the order that you see them. Okay, so here's what I'm going to do. I'm going to go back to that problem that we just did by factoring, and I'm going to show you that we'll get the same solutions using the quadratic formula. And then we're going to move on, and basically the rest of the time today is just practicing the quadratic formula. So here goes. Example 1, this is my example. So help me out here since it's our first problem we're doing together. What's the value of a on this problem right here? 1. It's the number in front of the x squared. A is always the number in front of the x squared. What's the value of b on this problem right here? Negative 6. Negative 6. The b is always in front of the x. It will never be anywhere else. And then what's my value of c? What's my last number? Thank you very much. I appreciate the participation. Negative 55. That's excellent. Once you've identified the numbers and once you've memorized the quadratic formula, it's just plug and shove. Okay, so here we go. My solutions, my values, my x's are going to follow this format right here. Negative b. Well, if I have negative, a negative 6, what does that turn out to be? Positive 6 plus and minus. There's two solutions. There's what I get when I add these numbers and what I get when I subtract. I've got a square root. By the way, on YouTube, there's some cute little songs that people have invented to remember the quadratic formula. So if you think musically, that might be a good thing for you to do. Play one of those videos while you're in the car. You'll definitely remember it. And so now b squared, negative 6 squared. What do I get when I square negative 6? Positive 36. Yes, great job. Minus 4 times a, which is 1, and c, which is negative 55. All over 2 times a. 2 times a is 2 times 1, or it'll just be 2. All right, so I'm seeing on my worksheet, this is the first semester I'm doing this. I should have allotted some extra room, so sorry about that. You can write on the back if you need to, or you can take another one if you want, that's fine. So I've got 6 plus or minus. When I'm doing my arithmetic, I always start underneath that square root. And in fact, I always start with the multiplication there. So I'm just going to start with my negative 55. So I've got negative 55, and then I'm multiplying times 1 times negative 4. And I end up with positive 220. So that's 36 plus 220. Now I'm writing extra steps. I understand that you could have just added the 220 and the 36 now, but I just want to be thorough for your notes on this first one. So then I've got 6 plus or minus the square root of 256 divided by 2. 256 does turn out to have a perfect square root, so that's going to be the square root of 256 is equal to 16. If this square root works out perfectly like this one does, that means the problem would have factored. If this square root doesn't work out perfectly, simplify it if possible. And if it doesn't simplify, just leave it. Okay, well, I'm not into decimal answers in this class. That's if you're in physics or an application, you'll give decimals, but we're just going to give exact answers in here. So I have 6 plus or minus 16 over 2. And in case you're confused about that plus or minus symbol, all it's telling you is there's two solutions. So I'm going to first do the solution where I add them. So 6 plus 16 is 22 over 2. And then I'm going to do the solution where I subtract them. So 6 minus 16 is negative 10 over 2. That's what the plus and minus means. It means there's two problems, and to save space, because math people are fundamentally lazy, they invented a new symbol, okay, so that you didn't have to write it more than once. And so 22 over 2 is 11, negative 10 over 2 is negative 5, and so I get the same solution set, which I promised you we would. We would get negative 5 and 11, and there we go. Yeah?
We have to keep the fraction, or you just divide the two.
Yeah, you have to reduce your fraction there. So I do need to divide the 2 into both sides like we just did. If you get an answer that turns out to be you can get fractions, so just make sure they're reduced. And if you fully reduce them, it's a good answer. Okay, so I think in fact the one you're about to do might have a fraction as its answer as well. So go ahead and do exercise 1 right next door. Plug and shove. See how you do. All right, so I'm just going to get going on this one, and we can correct any mistakes you've made so far. And then again, the rest of our class is just practicing this, because this is an important skill. We don't go back over the quadratic formula in the next class, college algebra. It's assume that it's knowledge you're bringing in. And that we will use it. So I'm hoping that you'll get nice and good at this. So my value of A, B, and C. A is 4. It's always the number in front of the x squared. The B is negative 11. It's always the number in front of the x. C is negative 3. Those signs are important. Okay, so if there's a minus there, bring it as a negative. Okay, you have to have that. So then again, it's plug and chug. Once you've identified the A, B, and C, and you know your quadratic formula. So negative B, well, negative 11, that's positive 11. So 11 plus or minus, there's 2 solutions to this. B squared, negative 11 squared is 121, positive. Minus 4 times A, which is 4, and C, which is negative 3. All of that is the numerator. The denominator is 2 times A, so 2 times 4. Anybody struggling to get the numbers in the right places? Okay, you've got the quadratic formula right on that page, so looking at it and using it while you're looking at it, that will help you remember. Yes? Because you're squaring B. And anytime you square a negative number, a negative times a negative is a positive. Okay, great question. That's a common mistake. So in case you didn't hear it, the question is, why is 121 positive? Because when you take B and you do B squared, negative times negative makes a positive. Okay, that number there will always be a positive number because you're squaring. Okay, so continuing on, I'm just going to slide my paper here and see if I can squeeze this in. So I got 11 plus or minus the square root of. So underneath the radical, negative 3 times 4. Negative 3 times 4 is negative 12. Negative 12 times negative 4 is positive 48. So I've got 121 plus 48. On the bottom, 2 times 4 is 8. Underneath that radical, 121 plus 48 is 169. I recognize that from my perfect square list. That's 13 times 13. So I've got 11 plus or minus 13 over 8. So my first solution is what I get when I add the top. When I add the top, I get 11 plus 13 or 24 over 8. When I subtract the top, 11 minus 13 is negative 2 over 8. And when I reduce those fractions, I get my 2 solutions for my solution set. And so here's my squiggly. I'm going to do the negative one first. Negative 2 over 8 reduces to negative 1/4. 24 over 8 reduces to 3. And there we go. There's my 2 solutions to exercise 1. Once again, because that root worked out perfectly, that was a perfect square, what that tells me is I could have factored that if I had wanted to, if you'd seen that. Now on my test that you're going to have on Tuesday, I don't put one, there's not ones that are factorable. I put 3 of these on there, and they're all, you're gonna have to use the quadratic formula. On the final exam, there is one that's factorable, but even if it factors, you see, you can use the quadratic formula. You don't have to mess with factoring if you don't want to. Okay, so, all right, example 2. Before you get going on example 2, okay, my purpose for this example is, or I guess it's my example, so I guess I'll go ahead and do it. What do I have to do first before I can do anything else on this problem? You got to set it equal to 0. It's got to be in the proper form. So that means I'm going to bring the 8x, I'm going to bring the 1 over to the left-hand side of this equation. So I'm going to subtract 8x. I'm going to add the 1. And here's the equation that we are going to solve. It's going to be 4x squared minus 8x plus 1 equals 0. Make sure you write it in descending order. Make sure everything's on the same side of the equation. Doesn't matter which side you pick. I picked the left. You could have done the right, but I like my x squared term to be positive. Makes using the quadratic formula a little easier. And so there we go. So now my value of A, B, and C. Okay, same thing we did before. A is 4, B is negative 8, C is 1. And now I'm going to use the quadratic formula. So my x's, my values are negative b. So again, negative 8 is positive 8 plus or minus square root of b squared, negative 8 times negative 8 is positive 64, minus 4 times a, which is 4, times c, which is 1. All of that entire thing is the numerator. So I draw a nice long division bar there underneath the whole thing. And then the denominator is 2 times a, so 2 times 4, or 8. After you've done a few of these, you're going to find places that you can cut corners and save a little time. Okay, I understand that. So now in the numerator, I've got 1 times 4 is 4. 4 times negative 4 is negative 16. So I have 64 minus 16 underneath the radical. 2 times 4 is 8 in the denominator of the fraction. (64 minus 16, that is 48, I believe. So now for the first time, I have one that is not going to, this was not a factorable problem. You could have tried to factor it all day. It's not going to work. But I can simplify that radical a little bit. Okay, so this is just applying a skill that we did in section 3, I believe, where we did the product rule of radicals and we applied it to simplify. So 48 has a perfect square factor. 48 is 16 times 3. Okay, I'm writing out all the steps here so that you can see everything that I'm doing. And so remember, the product rule of radicals says that you can consider each thing underneath the radical separately. So the square root of 16 is 4, and then I have the square root of 3. Almost done with this problem. I'm going to reduce this fraction, but I have 3 terms. So remember this about reducing, because division is distributive just like multiplication is. If I'm going to reduce, I have to be able to reduce everything. Is there something that goes into all 3 of these numbers, 8, 4, and 8? Is there one factor? 4 does. So I can reduce everything here by a factor of 4. So 4 goes into 8 2 times. 4 goes into 4 once and just leaves 1 square root of 3, or just the square root of 3. And then in the denominator, 4 goes into 8 twice. Please, 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 I've mentioned this before, avoid this temptation. I know you want to do it. I know you want to say 2 divided by 2 is 1. I get it. Okay, it looks like it's right there. But remember, you cannot just cancel one part of the numerator. Okay, you can't just cancel terms. Okay, so it's either all or nothing. And there's your 2 answers. I'm going to leave them as one thing. You can separate them. So I'm just going to find a little space. I'm probably just going to get a new sheet so that I don't keep cluttering this up. So my solution set is, I like to write it just as one thing, 2 plus or minus the square root of 3 over 2. You can write it this way if you feel like it. This is equivalent. But I'm not going to, in general, write it like this. You can do 2 minus the square root of 3 over 2 is the first solution. And 2 plus the square root of 3, you can separate them in 2 separate entities if you want to. Okay. No real reason to do that, but some people like to. All right, so go ahead and do exercise 2. It's the same sort of business. Have fun. All right, so let's check out how your work's going. If you got something different than me, that is a great opportunity to ask a question. You can see we're doing the same thing over and over to get comfortable doing this because it's important. It's our last thing for the semester. So just make sure you're leaving here feeling pretty good. So first thing I've got to do is I've got to add that 5x to both sides because whether you're factoring or whether using the quadratic formula, you have to have it equal to 0. Okay, so same first step. So that means that the equation I'm solving is 3x squared plus 5x plus 1 equal to 0. So my value of A is equal to 3. My value of B is equal to 5. Value of C is equal to 1. Any problems so far? We doing good? All right, don't be shy. So now I'm going to just plug and chug. So my solutions, my x's are negative b. Well, this time for the first problem, b is positive. So when I do the negative b, it's going to be negative 5 up top, plus or minus the square root of b squared. So 5 squared, 5 times 5 is 25, minus 4 times a, which is 3, times c, which is 1. All of that is over 2 times a, so 2 times 3. I saw some movement out of the corner of my eye. Is a question? Anybody over here got a question? We doing all right? Okay. Don't want to miss anything. All right, so here we go. So negative 5 plus or minus. Again, I'm writing out all the steps. You are welcome to consolidate as you're able. 1 times 3 is 3. 3 times negative 4 is negative 12. So 25 minus 12. In the denominator, 2 times 3 is 6. This one works out really nice because I've got negative 5 plus or minus the square root of 25 minus 12 is 13. 13 is a prime number. There's no perfect square factor of that. So I'm done. When there's no radical to simplify, you're good to go. So all I'm going to do now is write that as my solution set. So here's my squiggly, my brace. And I'm going to say, okay, my two solutions are negative 5 plus or minus the square root of 13 all over 6. Remember that 6 is underneath the whole thing. It's not just under the negative 5 or it's not just under the radical. Okay, that division bar is underneath that whole binomial. If you got a question, ask it. If not, go do exercise 3. All right, I'm going to get started. If you're working, keep working. I'm not trying to rush you. I'll catch up to you and we can compare notes. So first thing I have to do is subtract that 14x from both sides. So the equation that I'm going to spend my time solving here is 2x squared minus 14x plus 19 equals 0. So that tells me that my value of A is 2, B is negative 14. Those negatives are important. C is 19. Quadratic formula, negative B. So B is negative 14. So negative B is going to be positive 14. Plus or minus square root of B squared, negative 14 times negative 14. Is that 196? All right, look at that. I'm doing mental arithmetic like a champion today. Minus 4 times A, which is 2, and C, which is 19. All of that is over 2 times A, so 2 times 2, or you can just skip to the finish line and write 4 there. So in the numerator, underneath that radical, that's where all the fun stuff's happening. So I have 196. 19 times 2 is 38. And then 38 times negative 4 is negative 152. Um, 196 minus 152 is 44. So I can see, even though the square root of 44 is not a perfect square, I do have a perfect square factor that I can see. What's the perfect square factor? Yep, perfect. Well said. Again, I'm writing out all the steps, but I'm assuming most, if not all of you, have done enough of these simplifying that you could probably do a lot of it in your head. That is great. I'm happy about that. If you do, I'm happy if you write it down. Doesn't matter to me. I just want you to get it right. So the square root of 4 is 2. Square root of 11 over 4. And then one more time, I pretty much put everything in this problem for you. I can cancel something. Something reduces. What factor can I divide into all 3 terms? 2. Okay, so 2 goes into 14 7 times. 2 goes into 2 once, just leaves square root of 11. 2 goes into 4 twice. And there's my 2 solutions. So my solution set looks like this. 7 plus or minus square root of 11 over 2. So far, so good. We doing all right? Okay, I hope so. There's no reason to not be doing all right. Just let me know. So I'm going to go back to my other sheet where I have room. We're going to do example 3 now. Okay, so I'm not flipping the sheet. I'm just getting some clean space here because I didn't leave enough room on the worksheets. So I'll have to fix that. So this is my last example for the semester, I believe. I don't know what's on, I don't remember what's on the back here. So let me see, because if it is, I'm going to be excited. Yep, it's my last one. All the rest are for you. Woohoo! My semester is just about done. So here we go, example 3. So we're going to go ahead and solve this. The reason it's my example is because of what kind of solutions we're going to get. I just wanted to do an example so that you weren't surprised doing the problem on your own. So A is 9, nothing different here. B is negative 6, and C is 5. I plug and chug, quadratic formula. So my x's, my solutions are negative B. So negative 6 is 6 plus or minus B squared. Negative 6 times negative 6 is positive 36, minus 4 times A, which is 9, and C, which is 5, all over 2 times A, so 2 times 9, which will be 18 in just a minute. Success in this problem is just about getting the right number in the right place. Once you're done with that, it's just an arithmetic problem. So here we go, 6 plus or minus the square root of 36. And so 5 times 9 is 45. 45 times 4, I think, is 180. I'll trust you. I believe you. You do your arithmetic better than I do. So there we go. So negative 180 over 2 times 9 is 18. So 36 minus 180, here is why I gave this problem as my example. Let's try this again. 36 minus 180. There we go. Beautiful. Negative 144. All right, and I'm going to stop there for just a moment. I'm going to let you catch up because this is the important part. All the rest of that is just like the other problems we've done. But what do I notice about that square root? What makes this problem interesting? You got negative. So I'm going to have, what kind of number is my answer? Imaginary number. This is going to be a complex answer. Complex numbers can be solutions to quadratic equations. Okay, so that's why we talked about complex numbers before doing this as the very last section of the semester. So we'll finish this up. I've got 6 plus or minus. The square root of the negative is I. The square root of 144 is 12. So 6 plus or minus 12i over 18. Now here's something you do when you have a complex number that is a little different than when the other problems when we just had regular square roots. When you do have a complex number, I am going to take the 18 and I'm going to divide it into both sides. Okay, so that I have my real part and my imaginary part, because that's the format of a complex number. So I'm not going to just reduce it like this. You can reduce now if you want, but I'm going to split it apart. So my real part is 6 over 18, which I'll reduce. And you can do that all in one step. I'm just trying not to do too many things at once. Plus or minus 12 over 18, I. My real part, my imaginary part. And so I'm going to reduce this. I'm going to write it in my solution set right here. 6 over 18, 6 goes into both of those and creates 1/3, plus or minus 12 over 18, 6 goes into both of those and is 2 over 3i. And there's my two complex number answers. So that is something I would like to see when you do this on the test. If you get a complex number, okay, then to take that denominator and divide it into both so that you create the two complex numbers. All right, flip the page. Exercise 4, go for it. All right, so my value of A is 1, my value of B is 4, my value of C is 13. So here's my quadratic formula, my solutions, my x's are negative b. So since b is 4, negative b is negative 4, plus or minus square root of b squared. 4 times 4 is 16, minus 4 times a, which is 1, c, which is 13. All of that is over 2a, or 2 times 1. So I will take care of that, what's under that radical, making that look a little better. So 13 times 1 is 13, times negative 4, that is negative, what's that, 52? 2 times 1 is 2. 16 minus 52, that looks like it's going to be negative 36. So once again, we got a complex number. So I have in the top negative 4 plus or minus the square root of negative 36 is negative 6i. No, it's not. That was crazy. Let's try again. It's just 6i. Don't know why I said negative there. Sorry. Just to add a little confusion, I guess. So I've got negative 4 plus or minus 6i in the top, and then I've got 2 in the bottom. And then again, because I have a complex number, I am going to divide that 2 into both parts. So negative 4 over 2 becomes negative 2, plus or minus 6 over 2 becomes 3i. And there's my solution set, negative 2 plus or minus 3i. That's my end result there. All right, down to the final 2 problems. The next one, exercise 5. My whole purpose for putting exercise 5 on there is just so that you don't forget that this has to be equal to 0. So you've got a little work to do to get that problem started. You've got to do some multiplying and then bring the 10x over. Then at long last, you'll be able to solve the quadratic equation. I'm just going to give you a nudge. So I foiled here and got x squared plus x plus 5x plus 5 equals 10x. Collected my like terms. I got x squared plus 6x plus 5 is 10x. I'm going to bring the 10x over by subtracting now. And so then this, I'm going to give you another 90 seconds or so. This is the problem you should be solving now. We've got x squared minus 4x plus 5 equals 0. At long last, that's what you're going to use the quadratic formula for. All right, just for time's sake, here we go. So my solutions are going to be negative b. So b is -4. So negative b is +4 plus or minus the square root of b squared. So -4 times -4, that is 16, minus 4 times a, which is 1. C is 5 over 2 times a. So 2 times 1. So that is 4 plus or minus the square root of 16. 5 times 1 is 5. 5 times -4 is -20. So that becomes 4 plus or minus 16 minus 20. That is -4. And so that's 4 plus or minus 2i over 2. I can divide that 2 into both parts again. And so 4 over 2 is 2. 2 over 2 is 1i. So there's my two answers, which I then write as a solution set. And so 2 plus or minus I. There's two answers. There's the complex number 2 plus I, then the complex number 2 minus I are both solutions of that quadratic equation. All right, one more. This is it. Last problem for the semester. I'm just going to slide this a little bit. I think you can still see the bottom of that on the screen. So go ahead and do exercise 6. That'll finish us up for the day. All right, so here goes. A is 2, B is -7, C is 2. Here's my quadratic formula. We've done this so many times. Hopefully that's a good start for you remembering this. So -b, -7 is 7 plus or minus square root of b squared. -7 times -7 is 49. minus 4 times a, which is 2, and c, which is 2. All over 2a, 2 times 2 is going to be 4, but I'll just write 2 times 2. And so 7 plus or minus the square root of 49 minus 2 times 2 is 4. 4 times 4 is negative 16. 2 times 2 is 4. Underneath that square root, 49 minus 16 is 33. And that's about it. That radical doesn't simplify. So there's my solution set. 7 plus or minus the square root of 33 over 4. And I am done.